Welcome to Metaminds Academy. This is a lecture series on matrices. In this video, we are going to learn rank of a matrix and we are going to solve some problems to find the rank of a matrix. Now let us define the rank of a matrix. So before going to define the rank of a matrix, we try to define the concept of minor. Right? So you are given a matrix A equal to Aij. Right? So how do you define the minor? If we select any R rows and R columns from a matrix A, deleting the all other rows and columns, then the determinant formed by these R into R elements is called a minor of the matrix A of order R. Right? For example, suppose this is the given matrix A. Now this is a 3 by 4 matrix. Right? 3 by 4 matrix. And the rank is defined for all kinds of matrices. Right? Irrespective of the order. You can have a square matrix or a rectangular matrix. It doesn't matter. Right? Now, how do you define the minor? Here, we have to select R rows and R columns by deleting all other rows and columns. So now, I take C1, C2, C3, R1, R2, R3 and C1, C2, C3. Then what you are going to get is the determinant of first 3 rows and first 3 columns. That means we have to eliminate the 4th column. Right? So 1, 2, 3, 2, 5, 5 and 1, 4, 5. So the determinant of first 3 rows and first 3 columns means this column should be eliminated. Right? So this is a minor. Its value, you are going to get some value for this. Right? This value is called a minor of A. The determinant is called minor of A. Right? And this is a 3 by 3 minor. This is a 3 by 3 minor. How many 3 by 3 minors you will get? Right. If you want to get 3 by 3 minors, you have to select all 3 rows. But you have possibilities to select some of the 3 rows out of 4. So you have 1, 2, 3. You have 4. Out of 4 columns, you have to select any 3. 4C3 or 4C1. So 4C1 is 4. You can select 4 ways. That means you will get a 4 3 by 3 minors. 4 3 by 3 minors. Now let us write a minor of order 2. Order 2 means what? I am taking R1, R2 and C1, C2. So what is the intersection? It is 1, 2, 2, 5. R1, R2 and C1, C2 means the common elements are these 4 only. 1, 2, 2, 5. This is 5 minus 4, 1. Right? So this is one minor. And you can write so many 2 by 2 minors you will get. So many 2 by 2 minors you will get. So minor of order 2, this is a minor of order 2, this is a minor of order 3. Right? And if you observe, one important point here is, even though the matrix is of order 3 by 4, the matrix is of order 3 by 4, you cannot have a minor of order 4. Because minor is a square one, the determinant of the square matrix, right? Determinant is meant for only square matrices. And you cannot have 4 by 4 matrix of this, right? There are only 3 rows. So you can select a maximum of 3 rows. So that is how you cannot write 4 by 4 submatrix of this. So a matrix is said to be of rank R. Right? If it has at least one non-zero minor of order R and every minor of order higher than R vanishes. That means, for example, if you take a matrix of order 3 by 4, right, then you cannot have minors of order 4. You have already seen this, right? So you can have a minor of order maximum 3. Therefore, the rank can be maximum 3, or it can be 2, or it can be 1. So we do top-down parsing. First we check whether it is 3. If it is not, then we go for 2, then we go for 1. Right? If the rank of the matrix A is equal to 3, if, then what does the definition tells? That means you can find a minor of order 3 which does not vanish, which is not equal to 0. That means you can find a 3 by 3 minor. You can find a 3 by 3 minor which is not equal to 0. And what is the second point? Every minor of order higher than R vanishes. So higher than R means higher than 4, 3. Higher than 3 it is 4. And you cannot have minors of order 4. Therefore, there is no need of checking the second point. Right? If the rank is not 3. Right? If the rank is not 3. If rank is equal to 2, means all 4 minors of order 3 are equal to 0. The determinant of all 4 minors, minor itself is a determinant, right? So the 4 possible minors values are zeros, right? Because of order 3 are zeros. Because we have assumed that R is equal to 2, every minor of order higher than R should vanish. So if rank is 2, higher than 2 is 3, so all minors of order 3 must vanish. And in addition to that, the first point is you must be able to find a 2 by 2 minor. Of course, you will get so many 2 by 2 minors from this. You have to find at least one 2 by 2 minor which does not vanish. Which is not equal to 0. Right? So suppose rank is not equal to 2. Rank is not equal to, then rank must be equal to 1. Right? If rank is equal to 1, what should happen? Then all minors of order 3 by 3 must vanish. All minors of, because what the second point is telling, every minor of order higher than R vanish. Higher than R means higher than 1. Higher than 1 is 2 and 3 here in this particular matrix. Okay. So all minors of order 2 by 2 and 3 by 3 must vanish, and you should be able to find at least one minor of order 1, which does not vanish. So minor of order 1 means what? It is a single number. Right? So at least one non-zero number if you can find in this, then after the rank must be equal to 1. Right? So you cannot have rank less than 1. That means you cannot have rank 0. Because rank is 0 means what? All the entries in the given matrix are zeros. Then it is a 0 matrix. Then there is no purpose in finding the rank of the matrix. 3, 1, 2. Right? The determinant of this matrix is 1 into 6 minus 1, 5, minus 2 into 4 minus 3, 1, plus 3 into 2 minus 9, minus 7. So 5 minus 2, minus 21, 3 minus 21, minus 18, which is not equal to 0. So we are able to find a 3 by 3 minor which does not vanish. Therefore, the rank of the given matrix is 3. You need not check for 2 and 1. And if you take another matrix, A equal to, right, then what is the determinant of this matrix? It is 1 into 20 minus 12, minus 2 into 5 minus 4, plus 3 into 6 minus 8. It is 8 minus 2 minus 6 equal to 0. So because the determinant of the given matrix is 0, you cannot find a minor of order 3 by 3, right, which does not vanish. All minors of order 3 by 3 are zeros. All means what? You have only one here in this particular case. Okay. All minors of order 3 by 3 are 0. Now we check for a minor of order less than 3. You can instantly find so many minors of order 2, 1, 2, 1, 4. If you take 1, 2, 1, 4, it is 4 minus 2, which is 2, does not vanish. Yes. I could find one minor of order 2, which does not vanish. And all minors of order higher than 2 are vanishing. Therefore, rank of A must be equal to 2. Procedure to find rank. Procedure to find the rank of a matrix. Reduce the given matrix. Reduce the given matrix A to its echelon form. Echelon form, first of all. This is the first step. And then the second step is the number of non-zero rows. Non-zero rows. The number of non-zero rows in the echelon form of the matrix A is equal to rank of the matrix A. Right. Now let us solve a problem based on this concept. So coming to this problem, find the rank of the matrix A by reducing it to its echelon form, row echelon form. In the reduction, in the procedure, we use only row operations, remember. Okay. So what we have to do in the row echelon form? We have to make these three entries zeros using this entry. What we have to do is R2 implies R2 minus R1. Because how to get 0 here? This minus this. Okay. So A is similar to first row. We are not going to make changes to the first row. 1, 2, 1, 2, 0, 3 minus 2, 2 minus 1, 2 minus 2, 0. Next, we need to get a 0 here. For that, R3 implies R3 minus 2R1. You multiply the R1 by 2 and take the difference. You will get 0 here. So R3 minus 2R1. 0, 1, 0. Okay. Next, make this entry 0. R4 implies R4 minus 3R1. So if you do this, you will get 0 here. 7 minus 3 into 6, 2 is 6. 7 minus 6, 1. 4 minus 3, 1. 6 minus 6, 0. Right? So if you carefully observe, here, this is not in the echelon form because the number of zeros here is 1. Here number of zeros 2 before the first non-zero element. Here again 1. Right? Either you have to swap these two, R3, R4 to get a number of zeros, right, increasing order. But if you observe, R2 and R4 are same. Right? When two rows are same, you can subtract one from the other one. R4, you can take R4 minus R2. Then what happens? A becomes no changes in the first row, 1, 2, 1, 2. Second row, there is no changes. 0, 1, 1, 0. 0, 0, 1, 0 is the third row as it is. Fourth row is R4 minus R2, 0, 0, 0. Here last row is 0. Right? That means you have only 3 non-zero rows. How many? 0 row means what? A 0 row means all the entries are zeros. A non-zero row means at least one entry is non-zero. It is called a non-zero row. So you have 3 non-zero rows here. Therefore, rank of A is equal to 3. Coming to this problem, find the rank of this matrix using or by reducing it to echelon form. Okay. So how to make this into echelon form? It is not in the echelon form in the beginning itself. You see, you have a 0 here. If you have a 0 in the place of A11, how to make these three entries 0 is not possible. Therefore, as a part of elementary operations, you can swap two rows. So I swap R1 and R2. In fact, you can swap R1 and R3, R1, R4 also possible. I take R1, I swap R1 and R2. Therefore, A is similar to, I write R2 in the place of first one, 1, 0, 1, 1. Second row place, first row comes to the second one, 0, 1, minus 3, minus 1. And there is no change in the remaining two rows. 1, 1, minus 2, 0. Next. Now we need to make these two entries 0. This is already 0. Right? So how to make these three 0? R3 minus 3R1. And R4 minus R1. So now A becomes, A is similar to, no change in the first row, 1, 0, 1, 1. Right? Next, there is no change in the second row, 0, 1, minus 3, minus 1. Now third row, R3 minus 3R1 is 0. This minus 3 into this, 1. This minus 3 into this is minus 3. 2 minus 3, minus 1. R4 is already 1, 1. So how to make R4 0? We have written here the equation R4 minus R1. So it is 0. This minus this 1. Minus 2 minus 1 minus 3. 0 minus 1 minus 1. Now if you observe, R2, R3, R4 are all same. Right? Now I can make R3 and R4. R3 implies R3 minus R2. Because we have to use R2 to convert these two entries 0. Right? R4 implies R4 minus R2. Then what happens to A? It becomes similar to 1, 0, 1, 1. There is no change in the second row. 0, 1, minus 3, minus 1. And this is 0, 0, 0, 0. Because same rows. R3 and R2 are same. R3, R4 and R2 are also same. Now we have two 0 rows and two non-zero rows. Right? So the number of non-zero rows in the echelon, this is in the echelon form, right? Therefore, the number of non-zero rows in the echelon form of A is 2. Therefore, rank of A is equal to 2EL. Okay. That is the end of lecture 4 on matrices. Please subscribe to my channel if you have not subscribed it. Please like this video. Share this video with your friends and classmates. And also give your valuable feedback in the comment section. Thank you so much. We'll meet in the next video.